Hello the internet and welcome back to my channel. Today on the bench we have this LivingControl Music Server. These used to be part of a whole house entertainment system. It's a networked media server basically, and it works with some other boxes like amplifier boxes, wall touch panels, mobile apps, Windows apps. The idea is that this is a multi-room system, so each room is amplified by a different box, and at the touch of a button through a wall touch panel or your mobile application, you can basically stream your music and, if I'm not mistaken, video as well to that specific room. Now, the system is very much obsolete, but a friend of mine has his whole house wired to work with the LivingControl system, so he's got one of these servers as a spare unit, and apparently it doesn't work, so he asked me to take a look. So I'm told that this unit powers on, but just it doesn't do anything. It's supposed to come up with something on screen and it doesn't do anything. I don't know that myself, so I got power plugged in. I'll turn the mains on and see what happens. 3, 2, 1, go. On off button somewhere? Ah. Okay, well, we need to replace the fan. And finally the fan stopped making the horrible noise, but obviously it needs a replacement or needs some attention. And yes, this thing doesn't do anything. It says Music Box 3 powered by StarTide. And I'd say I understand it should come up with some different messages. So I would say let's open it up and see if we can see anything happening inside. Right, that's the guts of this unit, and I guess we have good news. This looks like to be a PC-based box, because that's a small motherboard. I can see, yes, that's definitely that's a very, very small one. That's like a micro ATX motherboard. I guess that's where the CPU is. There's an additional board which is connected to this 90-degree riser, which I guess is yes, probably like some sort of a sound card. We got the Ethernet here, which is going at the back of the motherboard. That's I guess that's the digital sound going to a coaxial, and we got the VGA output coming straight here at the back of the unit. We have one hard drive here and power supply, DVD player, I guess. And that's the front panel, which I'm assuming is probably at this point a USB device. If it's not a USB device, I can see something connected to serial, which is probably connected here at the back. And there's something connected here, which is probably a USB header, which is going at the front where the front panel is. So that makes things a bit more, I don't want to say easy, but at least more manageable, because it's not like some kind of obscure machine that you need to figure out what's going on. It's just a motherboard. Now, right off the bat, I think I can see what the problem is. Let me show you. And I guess that's not going to help with the motherboard. These are capacitors, and I guess they're close where the CPU is, and I can see blown capacitors under the heatsink as well. So chances are the reason why this system doesn't power up, which is basically why the motherboard is not powering up, is that the capacitors are gone and just I need to replace them. Now this thing is a bit dusty, so I guess the first thing I'm going to do, I'm just going to use my air compressor onto this and get rid of the dust. And then I'll have to remove the heatsink, remove the motherboard, and replace those capacitors. And this is the sound card used by this unit. It's an M-Audio Revolution PCI card revision 4, which again happens to have several audio outputs. It looks like a 12-channel video sound card, plus, I don't know what that is, to be honest. It's, well, I'm assuming that's coaxial, even though there's also a coaxial on the motherboard. So I'm not sure what that is. Right, this is a special motherboard. That's the mobile CPU. We'll check in a moment what CPU is that. And this is the heatsink. Not sure where it's a paste or a pad here. Yeah, it's still kind of okay, but it's pretty dry. And this one as well. It's very dry, as you would expect. I mean, this thing's pretty old. Aha, this is not an Intel processor, it's a VIA. It's a C7 1500/400. So as the name suggests, this seems to be a C7 1500 MHz, and it's a single core, very low power x86 architecture basically, which was first sold in May 27th and 2005. So this is a pretty low power, low performance, I say, and low everything processor, but obviously was totally fine for something like this. Now, as you can see here, I got basically all these capacitors here are bulged. This is not, but I guess it's just a coincidence. These two are bulged as well. These two are not. This is bulged. And then we also have some damaged capacitor here, 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 and that's it. So more or less, I'd say this board needs a full recap because there are only a bunch of capacitors which are not damaged. Let me see if I got these capacitors, because the thing is they're pretty tall, which is great, so I don't have to worry about the height, but the diameter is pretty small. And I will have to make sure that they are the same diameter, otherwise they won't fit. So let me see if I got something available, otherwise I'll have to place an order, I guess. Now, removing components like this from a motherboard can be difficult. Reason is the motherboard is a multi-layer PCB, it's got ground plane, so basically if you try and desolder one of these tiny little legs, the heat is basically sucked away from the rest of the PCB. But what is the ground plane? In a nutshell, a motherboard is a multi-layer PCB where several layers with independent traces are sandwiched together. The vias are small holes on the PCB which connect traces on different layers. A ground plane is a large sheet of copper which is there to connect all ground points together. It's shown as a solid sheet on this animation because I'm not so good at using 3D software. I mean, this is PowerPoint. Obviously, other traces can go through a ground plane without connecting to it. As you can imagine, the ground plane acts as a large heatsink, drawing away the heat from a soldering iron or hot air station and distributing it across the whole area. Well, the first thing you want to do is to melt some leaded solder on top of the lead-free solder which you are going to find on this board to lower the melting temperature. Then I'm going to use my hot air station to warm up the area and just help out with the process. Otherwise, it's not going to happen, especially on tiny little things like this. It's going to take absolutely forever. I'm not saying it will be easy with the hot air station, but it should help. Despite what I've just said, I really could not remove all the solder from the capacitor's leg with my desoldering gun. Half of the hole was still filled with solder. I tried quite a few times, but I had zero success. Eventually, I thought of making a big blob of solder and just pull the capacitors off the board. That usually works fine, and I would clean the solder afterwards. But to my surprise, that was not an easy job either. I had my soldering iron standing in the blob of solder for several seconds and the capacitor was not moving at all. Eventually, I put my hot air handle on a stand and aimed it at where I was desoldering, so I had hot air and the desoldering iron in a blob of solder. And still, it took some time to get the capacitor off. I've done motherboards before and I know they can be stubborn, but this is the most stubborn I've had in my life. I could feel parts of the boards far away from where I was desoldering the capacitors getting hot very quickly, showing that a large ground plane was sucking away the heat and distributing it along the motherboard, which was acting as a heatsink. Cleaning those through holes was a massive pain in the neck as well. It just took me a lot of tries to finally get them all clear of solder. Eventually I did it without damaging anything, but I couldn't believe how difficult that was. Okay, so replacement capacitors have arrived. Now before I start replacing them, I was just curious to see how these existing capacitors test. Now I don't care to test something like this, because this will probably test as an unknown or damaged. What I'm curious to test is something like in between. Like this one, for example, is a bit bulged, but it doesn't look like electrolyte has escaped, even though I see a black spot on it, so that could be where it did escape. So just out of curiosity, let's plug it into the component tester and see how it reads. And it's taken a while and it doesn't read anything, so it looks like the capacitor is completely gone. Let's try another one. Same brand, same capacitance and same voltage, and again it's a bit bulged, but it doesn't look like there's been electrolyte escape. I'm just curious to see whether there's something which is in between being dead and working totally fine. And no, this is completely gone as well, so you would expect some kind of in-between, but no, as soon as they bulged, they are completely gone. Now, some of these capacitors actually look totally fine, so I'm curious whether, in this case, we got something in between, like the capacitance has changed, or the ESR is way too high, or whether the capacitor reads totally fine. And would you look at that? This looks perfectly fine. It's a 1500 microfarad, ESR is very low, so it looks like when it comes to these capacitors here, they're either completely gone or they work totally fine. That's pretty bizarre, I would say. I would expect the good looking capacitor to show some kind of stress, but they don't, at least not on this machine, I guess. So anyways, that was just totally out of curiosity. I would say let's start with the replacement process. Now, considering the difficulties I had removing those capacitors, I don't think that putting them back is going to be easy. Let me explain. So in theory, it's not rocket science. You plug a capacitor in, you solder the legs at the back, and it's done. But the thing is, these holes are plated internally, and the idea to do a quality solder joint should be that the solder is flowing up to the other end, which is, so if I'm soldering on the other end, on the other side, the solder will flow on this end as well. Now, I think that's going to be pretty unlikely considering how badly it went when I removed those capacitors. Now, to be honest with you, probably doesn't matter, because again, these holes are, or vias if you want to call them that way, plated internally. So if the solder melts on one side only, it should be totally fine. But I really would like to do a quality job for maybe educational purposes. So I think what I'm going to do is to preheat this board to, say, a reasonable temperature, say about 100 degrees Celsius using my preheater. At that point, hopefully the massive ground plane, which I could feel last time when I was desoldering, is going to be to such a temperature that my soldering iron is going to be happy to just flow the solder properly from end to end, from one side to the other. Then I think I will still use the hot test station to help me out, to just basically make a little patch of higher temperature and help with the soldering process. That being said, I completely appreciate I'm going to use leaded solder this time, so temperatures are lower, the process should be a bit faster and easier than last time. Okay, right, the board has reached about 100 degrees Celsius. I'll go ahead and turn the hot test station on, and let's see if it's easier to solder them back than removing them. The process of reinstalling the capacitors went well. I hope the solder managed to flow properly, as I don't have visibility on the other side of the board, as the capacitors are sitting on it. That said, it felt a bit easier, probably because I knew what I was expecting. Preheating definitely helped, but I definitely burnt my finger over this whole process. After removing all the spikes and a thorough clean, I'm happy with the outcome, even though I can see this area of the board is a bit toasted. That said, those look like V-core capacitors, so all traces around them are pretty chunky and less prone to damage. I don't see damage anyways. Not my best job probably, but honestly, the best I could do. So all I need to do now is to test this thing. Now, I don't want to put it back into its case. This is a regular motherboard. What I'm going to do, I'm going to plug it to my power supply. I'll put the heatsink back, the memory module on it, and I should have VGA output. What kind of VGA output, I don't know, but definitely I will have like a BIOS output of some sort. And that's telling me, hopefully finger crossed, that the motherboard is working. Right, this is the moment of truth. I've got everything connected, got my small power supply here, got VGA output going to my monitor, and the memory. The battery is in, but it's dead. Okay, let's give it a go. 3, 2, 1, go. There is life. Hey, it's working! Haha, fantastic. Well, I was a bit concerned about damaging the PCB with all that heat. Well, there's really not much you can do here, because obviously this belongs to that box, but I'm getting the memory battery failed, I'm getting CPU changed or something. So let's get a new battery, let's connect the keyboard and make sure that the board passes the post section, let's put it that way, and actually tries to boot from something. Okay, new battery's in, keyboard is in, let's power it up again and let's get into the BIOS. Okay, well, it's talking about CPU ratio and something. Hopefully I don't have to do anything special. So let's go into the BIOS here. Well, I guess it doesn't hurt to set the date, as I'm not sure whether this is ever going to be on the internet. To be honest, I'm hoping that whoever designed this system created some sort of a custom BIOS. The reason is a custom BIOS will have all the settings already set up. So if you lose the settings, like in this case, because of the of a low battery, you don't have to go through a BIOS and set things. So what I'm gonna do, I'm just gonna save and exit, because hopefully that's all it takes. Well, yes, the board is trying to boot, so I think that's all it took, just get into the BIOS and just save it, which is totally normal when you run out of battery. But yeah, let's put it back together, connect the hard drive and everything, and it should actually boot into something and do something. Now, I've hit a little stop in here, and I'm a bit surprised, because I understand this thing used to be very expensive. Now, because of this connector here, which I think is digital audio, it's a custom-made connector, it's one of the rewirable ones. The thing is, I'm definitely in the right position, because, well, I got one standoff, which should align with this hole on the board, and it aligns perfectly, so I'm in the right place. But, let me show you. I'm not sure how much you can see that, but the connector here doesn't align, and again the motherboard doesn't go in a different place. I mean the standoffs are attached to the chassis, so I guess I can probably squeeze this in, but that's its like in its resting position. This is how it would try and connect, which clearly is not going to happen. So all I have to do, oh my gosh, this is horrendous. I mean, I have to squeeze this in, but it's absolutely horrendous. The board is at an angle. It's just an horrendous design. Now, I remember struggling to remove this earlier on, but I didn't realize it was because of that. The board is at an angle. Let me see if I can show you, because this is pretty, I don't want to say interesting, but I'm not sure how much you can see, but if you compare the motherboard with this board is just twisted counterclockwise. It's horrendous. It's just a horrible design. I really don't understand. It's all mostly because of that connector there, which is hitting the power supply. Now, if I remove this connector just for a quick test, and yes, the post doesn't align, I mean, is this just, obviously that's how it would go, and as you can see, it goes in straight, perfectly fine, but now the post doesn't align here. I would have to push it a bit. Fair enough, you know, I have to bend the post. I'd rather bend the post than the board itself. But this doesn't fit now. This is just a horrible design. And honestly, I don't understand. Again, it used to be a very expensive thing. There's absolutely no reason. There's plenty of space here. So the board just needed to be 1 centimeter away that way. That wouldn't have been a problem. The board would have sat perfectly fine. Well, anyways, I'll just put it as it is. I'll just mention my friend. I think he's going to use this system as a spare system, or maybe for spare parts. The noisy fan turned out to be the CPU fan, which is a Sunon maglev fan. Maglev stands for magnetic levitation, so in theory it shouldn't have anything that could wear off and make noise, but clearly that's not the case. Unfortunately, there is nothing to lubricate on these fans, so it'll have to be replaced. Okay, everything is back together. I've got the monitor connected to it as well, so we should see what happens when it's booting, but we should also see some information coming through this LCD screen as well. I'm ready to power up? Yes. And yes, it's booting up, it's working, amazing. Well, it was pretty predictable, I would say. There we go, we got some dates, we got menus. Look at that, we got the user interface here. Well, I'm wondering if I can play some audio out of this thing. So I plugged, it's an RCA cable into one of the analog outputs here, one of the channels, which is then plugged into my active speaker, which is under the desk. And I don't know, I can see audio media here. There's a list of songs. Does it play?
A few questions that I need to know. How you could ever hurt me so.
Well, I can't really play that too long because otherwise YouTube will stop this video. But it's working, it's amazing. So there you go, LivingControl Server fixed. Let's take a quick look at the airflow of this case. Now, there are a total of 4 fans here. This 80mm Akaza fan is pushing air outside of the case. This other 80mm fan is blowing air onto the hard drive, so it's not getting air in or out of the case, and this is the CPU fan. This little 40mm fan was added by my friend, so let's ignore it for now. The fourth fan is inside the power supply, but it's getting air from a grill at the bottom of the case, and most of the air is going to be blown out at the back through this large grill. So the only fan taking care of getting air out of the case here is this one, which is blowing out. The idea is that fresh air is coming through the front vents and out at the back. But that's pretty inadequate, I'd say. Well, first, because it's only one fan for the whole case. Second, because hot air tends to go up, floating on colder air. The cover of the case is solid aluminum with no ventilation grill, so all the heat generated by the electronics will float on top of colder air and more or less stay there. No wonder those capacitors baked. They're basically wrapped around the heatsink with very little ventilation. This is another, I'd say, major design flaw of this case. Right, it's done, it's working totally fine. This is definitely kind of a unusual device for 2023. Now, I'm not familiar with this kind of devices, but I'm sure there is something much smaller and more powerful and more convenient nowadays. That being said, this friend of mine, he told me that he's got his whole house wired with these devices. This is the server, then you got the amplifier, you got control panels. There's a number of units which basically create a whole system, including Windows app, which I've just installed, and I got to say I'm impressed. It works like a charm. You just run it. He saw the box and basically showed that window, not a mirror, but it's just an independent window where I could select music. I clicked on it and it just started. So no configuration, no questions, no hassle whatsoever. It seems to be working totally fine. I understand there is an Android app as well, so I can see this type of system might still have some life in 2023. That being said, again, it's a massive unit. I'm sure nowadays with a probably Raspberry Pi, you can do something much easier and more flexible than this. That being said, I believe this is going to be the spare unit for this friend of mine, so hopefully I managed to give this unit a little bit extra life. It was kind of an easy repair, even though obviously those capacitors were pretty stubborn, so I think I learned something new, as my previous attempts were tough but not as difficult as this one, so lesson learned for next time. Well, that's it for today. I would really appreciate a thumb up down below if you enjoyed this video. If you didn't, well, I'm sorry, but I still hope to see you again here on this channel for my next videos. For now, you have a great day and I hope to see you again soon. Thank you. Bye-bye.